Have you ever considered how misconfigurations in Kubernetes could make your cluster vulnerable? Do we know how to prevent your cluster from being, an easy target for attackers? Hello everyone, I am Sari. Welcome to today's session on Kubernetes supply chain security. Uh, in this session, as you know, I have already pulled up this page from Digital Ocean official uh, documentation, community documentation page. So we'll explore like how we can harden the how we can harden the control plane and worker nodes, how you can secure your Kubernetes application and environment, and how you can protect software supply chain. So as we go through this documentation, this article, uh, we'll explore, as I mentioned, Kubernetes best practices, how you can protect your cluster, and also dive into practical like tools like Snake and Kubescape. So before demonstrating like how they can enhance your security posture through vulnerability scanning and all, let's understand typical architecture of Kubernetes cluster and understand possible weak points. So we have control plane. So it is responsible for managing cluster workloads and ensures desired state of your application. Where we have got like etcd, which is also for storing your key value stores, key value pairs of cluster data, which is connected via Kubernetes API server, and responsible for is a kind of entry point for all cluster operations via REST APIs, and which is again connected to Skurla. Skurla is responsible for assigning ports on each worker node, whereas and Cloud Control Manager is a, responsible for managing the like cloud specific API controllers. So as is again connected to cloud provider API, so as it is via communicates with digital voice and load balancer and digital voice and object storage. So where load balancer is responsible for like uh, you know uh, distributing the traffics to across ports, and whereas block storage for storing uh, your uh, something related to your database, right? So maybe it is your files or something is related to your images and all. And with that, we have a worker node where it's like proxy is responsible for handling networking. We have got Kubernetes is responsible for running your ports, ensuring your ports running on node. So we have weak points like HCD and Kubernetes API, so vulnerable to attacks if exposed publicly, whereas Kubernetes also like vulnerable to attacks if exposed publicly. So like as we know, like the digital ocean is something like it is a kind of Kubernetes managed service. So managed Kubernetes service that lets you deploy Kubernetes clusters without dealing with the complexities of installing and managing control plane components and containerized infrastructures. So let's understand like from this like control plane hardening where like you make sure like you secure the REST API, the Kubernetes API with authorization, authentication, TLS encryption, like yeah, make sure like your authentication is not set by anonymous, or your authorization is by default like always allow. So it should be treated to be like like we have to make it authentication by default, and like authentication via anonymous to be false, like that, and make sure the have this in your cluster configuration like for the Kubernetes API server, and regularly update the OS kernel libraries. When there is some release happens for Kubernetes versions, make sure you update those versions to minimize your risk, like to get it like low and to fix vulnerabilities, right? Use firewalls and network policies to minimize external access. You can use deny policy, allow policy for only necessary services, and do not expose HCD database publicly, as we mentioned, and limit access to critical components. And talking about working node hardening, avoid exposing kubelets or kube proxies publicly. Restrict public SSH access. Use VPNs for system administration. So yeah, I think this is something related to that. Okay, now, like application environment hardening, like you can scan YAML manifest for misconfigurations and set a strict permission for ports. We can use some kind of immutable file systems, root file system, like root access to like not to users, right? And you can maintain kind of, you can using some kind of for security standards, configure RBAC policies properly, and assign container images to ensure only trusted ones. You can use cosign tools like that. Use admission controllers to allow only signed images. For example, you can use Governor, where it's like allows to write policies. We can apply this on a cluster basis, which will, will not allow those images which are not signed. Apply network policies, as I mentioned, namespace isolation to control traffic, and probably scan the Kubernetes cluster. So we'll definitely look into that in our demonstration uh, when we come to that. So uh, let's view understand something behind that. The supply chain security scan. Make sure you scan application source code and third-party libraries for vulnerabilities. Regularly check container images for known securities. So it is now talking about the process of we can ensure end-to-end security for Kubernetes. You can see like we have Git as a source, source of truth, where we write the code, we manage the code, and push the code, and where after that, like configure the whole infrastructure. Sometimes we write deploy to Dockers for containers, and we also pull the image from Docker. So make sure you sign your image, as you can see here, like sign your image and push, and you can pull that image for your application. And you can, like make sure you create ingress controller to create your ingress gateway, where like you can manage your firewall, and also you give the logs, user access logs to not to like everyone, but make sure to specific users. You can maintain your ongoing scans, and also image admission control and other things like audit logs and all. So in case of DOKS, you don't have to worry. As I mentioned, it's already taken care by cloud provider. And so yeah, uh, so we can also look for like other tools like scanning vulnerability scans within your CI/CD pipelines. Like you can use Tecton, Jenkins, GitHub Workflows, where you can integrate those tools uh, to process those scanning, like predictably running scans within your Kubernetes cluster, evaluate security risk, and take the appropriate actions. So this is all about thing, I think, and like before using that, I think you make sure like you install Snake tool and Kubescape. So we'll go one by one. Let's start with Snake here. the instant vulnerability scanning tool, and we will dive into, like, it is, yes, it is open source, so you can use it for any purpose. Like, no need to worry about cost and anything like that. Pricing, it comes with the community edition. I'm not sure, but yeah, it has to be like that. So you make sure, like, install the CLI from the documentation based on your environment, right? So OS architecture and all. So I have already got it installed. I don't have to worry about like installing again. So as I can show you my versions right now, uh, it's 1.1294. So scan your project code from your current directory. So let's go to my code, my repository, and run this. Uh, paste subcommand to see how this works here. For known issues, 10 issues, and 57 vulnerable paths. So here you go. So I think it is giving you the possibilities of high severity vulnerabilities found in few of the libraries which I am using for this code. So this few are like medium severity vulnerability found here, and yeah, that's it. So what you can do is suggesting us to uh, to make sure. Let me make it bigger, right? To make it upgrade this version to probably in this among these versions, and here you go. So basically, as it has to go with the code. So when package your code, we containerize your code, your application, make sure you have like that, no vulnerabilities, no any kind of vulnerabilities on your code. And now scan your project from repository. Okay, it's talking about the open source scanning. Let's see how this works again. I'm not sure what is the difference between that, but what I understood, like, it's code scanning and it was open source scanning. Let's run this again, and it's it's not supported. I think it is gone like obsolete. Anyway, we'll try to find for Docker file and scan over here. Let's see where I go, and create containerized scanner and go for that file. Does it work like that? Okay, we need to first pull this, and then we can we can run through that Docker file. So first pull that one, right? So basically, this is kind of where where we can make sure uh, you have authenticate to your Snakes CLI as well. Since I have already done that authentication, I don't have to authenticate again. Now, if I keep the Docker file, I'm not sure it is going to work, but let's try. No, it's not going like that way. But what I can see here, that you have container. Uh, so what else we can see? Like we can follow the documentation as well, or you can try out like this. From here, like you can see trace for any vulnerabilities. So I'm not sure that we have to, you know, share the link to that. I can just try layers, test for any known vulnerabilities. Let's see what's we are going. Okay, could not detect image. So I think it is looking for local images. So I don't have any local image running here. So that's why it's not able to detect an image here to scan. So again, it's talking about an image name to scan, or I think what else I can do with that. If I try to mention file, will it work? Let's see. No, no, it has to do with the image scanner. So I don't think if I try to look for like this and look for help as I can get from here. Image. So it has to deal with the image. So as it is already, we have tried out with that Debian. So let's try with that and see how it works. Right. It is kind of anything related to their operating system. I think where it is going to scan the Docker file if there is any vulnerabilities because there are a number of layers, right? So basically, that's it for my side for this, you know, image scanning and all those things. But you can try out with the infrastructure code, infrastructure as code, like the, make sure your Kubernetes YML file configured. But I definitely want to try it out. Here you go. We have got the uh, image scanning from this. So you can see like it has found 33 issues, and you can see those few are critical severity vulnerability found in this. So it's talking about the image layer where it is to be introduced by base image. Again, those are the related base image. I think it has dealt with the image, I mean the base image. So we have to make sure it is maybe the stable version or the latest one. So yeah, I think it is great way to deal with that. So last one again, I want to go through the infrastructure code where I can see from my conf file. I don't see anywhere, but yes, it should be something related to there here, or for other things like we have chart. So inside here I have mentioned the templates. So let's try that out and see how this works for this scanning the whole file. So we go to chart here, then we go to templates, and that's it. I think it should work now, but it's looking for directory, or yeah, it is all about directory. So I'm going to use that. Let's see how it works. Pass YAML. Okay, it is failed to pass the YAMLs. If I try to make it like this, it's going to give this output here. Let's see if there is any. Okay, so I think I have to deal with the YAML file. If I try to do that, what's output gonna be? Let's go to the deployment part now. There is any misconfiguration inside or in this deployment configuration file or not? Okay, so basically, it is related to the chart, like Helm chart. So it's not able to validate those YAML file using this sync. Make sure that you have, you know, the Kubernetes specific resources, uh, which has to be, configured using the Kubernetes uh, deployment resources. Then it should work. So since I don't have configured here, if I try to see for other ones, but I don't see. Anyway, if I look for the other configuration files, I can look for uh, from yeah from maybe from let's say tab file, and here we go. And I try to run that here. So what will be the output? I'm very much curious about that. So I am taking a little bit time of yours. So stick with me until the end. Keep it like this. See the fine. See how this works. Hopefully it should work now. And see finally what is going to be. Here you go. So we have three medium vulnerabilities, and the thing that is showing out like what are the vulnerabilities could be like medium ones is default like does not throttle default capabilities is without root user control is privilege escalation control and without loveliness probe. That's right, like without memory limit, which should make sure the life cycle of your board, with the liveness probe, right? So there's a great tool, I think, way to configure your Kubernetes resources and all. And if we have time, we can dive into the Kubescape, but I want to go through that uh, in our next video. So stay tuned to wait for this until this we cover this tutorial in our next video of this sessions helpful for you. And as Kubernetes security requires continuous effort from hardening infrastructure to securing application and the supply chain. By following these steps, regularly auditing your setup, you can significantly reduce risks, protect your cluster from threats. And yeah, hopefully we will see you again in our next video. Thank you for watching. Stay tuned.